A few weeks back, on October 14th, NASA launched the Europa Clipper, a space probe designed to study Jupiter's moon, Europa, looking for signs for if it can support life, or if it ever did. Now, obviously we're looking for life on Jupiter's moon, Europa, but why Europa? Now, Europa seems like an odd choice to look for life on. It's outside the habitable zone of our solar system. With so much radiation, in fact 1,800 times more than here on Earth, how will a space probe survive the harsh conditions? Is it even possible to survive a day on Europa like this? Well, the answer is yes. But first, we need to dive deeper into why NASA has chosen this moon to look for aliens. Because there's something special about it. On July 9th, 1979, Voyager 2 had its closest encounter with Europa. Here's what it found. What was strange is that the moon's surface was quite smooth in comparison to others. The moon had a lack of craters. Although Voyager 2 did not pass too close to the moon, the images were high enough quality for researchers to notice these dark bands that matched each other well. But still, no craters, which implies something had erased them. This inspired other missions, including Galileo's mission in 1989. One of the most significant findings showed how Jupiter's magnetic field disrupted the space around Europa. This implied that a special magnetic field was being created within Europa by some electrically conductive fluid beneath the crust. But what could this fluid be? Scientists suspect the most likely fluid to create this is an ocean of salty water. They found that intensely radiated salt turns into that exact same color. If there really is an ocean of salt water underneath the surface of Europa, this moon would really be vital for life. Now, I want you to think about how much water Earth has. Multiply that amount by 2. That's how much water we think is hiding beneath the surface of Europa. Even though Europa is a quarter of the size of Earth, Europa is still believed to have twice the amount of water. It is also believed that this water could be lying only tens of kilometers beneath the surface. No wonder Europa is so promising for life beyond Earth. They proved this in the previous Galileo mission. The magnetometer in the mission detected a strange deviation of Europa's magnetic field, which could only be explained with a secret layer of water underneath. As promising as this is, Europa is still extremely radioactive. But why? Well, it isn't all Europa's fault, but rather Jupiter's powerful magnetic field, about 20,000 times stronger than here on Earth. This field itself does no harm, but something near it does. The intensely hot environment of one of Jupiter's other moons. This moon contains some deadly volcanoes that shoot out tons of sulfur dioxide. Now the bursting sulfur dioxide gets trapped in the magnetic fields of Jupiter and began to spin around Jupiter rapidly. These can reach speeds of up to 3,000 kilometers per second. These spinning particles slam into other moons, creating radiation belts. Very powerful radiation belts. And yes, one of those moons is Europa. This would easily fry an orbiting probe, so how will the Europa Clipper survive this immense radiation? There's so much of it, in fact, if you stayed on Europa's surface for a couple of hours, you would die of the sheer amount of it. Well, the way the Europa Clipper will do it is not by orbiting Europa, but rather by orbiting Jupiter. It'll swoop in every so often and then come back so it can fly beside Europa, and then return to its original location. It can use its time at the original location to transmit that data back to Earth. This action will occur 49 times in total, swooping in and out every time. This is how the Europa Clipper will avoid plenty of radiation, as that would actually decrease the spacecraft's lifetime. NASA has improved their designs over the years with their spacecraft. as they learned in the Galileo mission I told you about earlier. The only reason we know about how powerful and dangerous these radiation belts were, due to one of our findings with the Galileo mission. You see, they found many glitches in the probe's images when it passed by Io. High-energy particles were being slammed onto the spacecraft, penetrating it with 3 times the amount of radiation it was created for. But luckily for us, this radiation does do some good. It proves how Europa could be the key to unlocking other life. The icy surface of Europa helps preserve the ocean below from ionizing radiation. So we've learned a lot from previous missions, including a way to collect samples of that precious water lying beneath the surface. But what is that way? Well, this strategy is not as simple as digging up a big hole, as that would take time. And as we learnt before, this mission needs to be carried out as quick as possible. So we need a clever solution. And we can use geyser eruptions to help us. Thin plumes of water jets shoot 160 kilometers high in the air, are what scientists suspect lies in Europa. You see, we are hoping that the Europa Clipper can determine the chemical composition of Europa's oceans to determine whether we are correct. So the probe could use a mass spectrometer to analyze and sample the fluid's chemicals. So the Europa Clipper doesn't even have to go on the surface to prove this. This shows the genius of the Europa Clipper's design. But there's more to it than that. This is the largest ever spacecraft built by NASA for a planetary mission. That might sound like not much, however this spacecraft spans 30.5 meters in length. It's also 5 meters in height. This is about as big as a basketball court. But the true genius is with the large solar arrays. These have to be big enough to sustain the probe's need to function properly. As Jupiter is further away from the Sun compared to us, it needs large solar arrays to accompany its needs. Also, the electronics are stored in a thick, compact vault which acts like a shield against high-energy particles. This strategy was used in another expedition to Europa, the Juno spacecraft, and proved to be successful. It'll also be able to detect non-ice parts of the Moon with a Mapping Imaging Spectrometer for Europa, or MICE for short. It'll gather data that'll help scientists learn more about the Moon's composition and chemistry. It works by detecting infrared light from Europa's surface and seeing how much it absorbs or emits. MICE will also be looking for certain types of salts to help determine how material circulates between the ocean and Europa's surface. Also, to help to understand Europa's geological history. This mission will cost about $5 billion in total, even with extensive changes being made to decrease the cost. One of these changes includes the route it'll take to get to Europa. You see, it won't just take a direct route to Europa, as that would be expensive. So NASA opted for the Falcon Heavy rocket instead of a much more powerful one. This did save much money, however the Falcon Heavy has lower thrust, meaning that it can't just travel the direct route to Jupiter. This means it'll have to fly by Earth and Mars for gravity assists. These gravity assists act like a slingshot, propelling the spacecraft forward. So although this does save $1 billion, this route is about 2.5 years longer. Europa shows strong evidence for an ocean of liquid water beneath its icy crust. Beyond Earth, Europa is considered one of the most promising places where we might find habitable environments in our solar system. The Europa Clipper will determine whether there are places below Europa's surface that could support life. I can't wait for the results, but we'll have to wait. Clear results will only come in about 2031. So until then, good luck to it. Make sure to like and subscribe if you enjoyed this. Thanks for watching, and I'll see you in the next one.